may be a genius climate scientist, which is actually not true in any way, but I also am going to use cheat sheets. So I will pretend to look at you guys, but I'm actually going to be looking down here. So thank you very much for the opportunity to share with you a little bit about what I do. There's a lot of stuff that goes on at NASA Ames here in Mountain View, everything from autonomy for Mars rovers to cells in space to atmosphere and biosphere of the Earth. And you all know that our atmosphere affects our daily lives in a variety of ways. Too smoky outside to go for a run. Fog will ground your airplane and mess up your entire plan for the day. And I tend to think about the atmosphere in two categories. Weather is sort of the physical properties of stuff, the wind, the temperature, and also the water, the precipitation and the moisture. So that's what, in my head, because I'm a chemist, is the boring weather. What I think is fun is the chemistry of the atmosphere, the molecules, the chemical composition. So you've heard of nitrogen and you've heard of oxygen. You've probably heard of ozone here with 3 oxygen atoms. And that we generally call air quality when we're talking about the air that we breathe. That's the stuff that I think is fun, and I want to tell you about it. You know about it, though, because you have an app on your phone probably that tells you about the weather, that tells you about the air quality, that you check and you say, do I need an umbrella or a gas mask today? But what you may not think about every time you look at those apps is where the information comes from that feeds into those. And that comes from sensors. It doesn't really come from your phone in most cases. It comes from a weather station, or it comes from some chemistry monitors that are on a rooftop in Fresno or on the Sutro Tower where they measure greenhouse gases. And they, as a variety of agencies, NASA, NOAA, the air districts. What I want to tell you about is the first satellite measurements, though, and those were NASA, actually, in 1960 on April Fool's Day, believe it or not, launched TIROS-1, the first successful weather satellite. Took pictures from about 400 miles up, got about 100-minute revisit time. So it's this closer orbit, this low Earth orbit, and you could see whatever you were flying over, but you have to go out to the higher orbit, this geostationary orbit, to get the disk picture where you stare down at, say, the storm track that's coming in off the Pacific. So you've seen this one. You can't see the red, but you're used to looking at this. Here's Baja. These are the storms coming in across the Pacific from GOES west. There's a west and an east, and this has really improved our ability to look at weather by being able to see it all the time. Orbital measurements of the composition of the atmosphere started in the 1970s when NASA started monitoring stratospheric ozone. Fortunately, that measurement began before the hole was discovered, so we have some data before then from orbit. Today, fast forward, we've got tons of satellites in orbit, and I want to show you 2 in particular. In fact, these are just the NASA satellites, so other countries have satellites as well. A lot of them are partnerships. So let me tell you about this one right here called AURA. It carries an instrument called OMI, the ozone monitoring instrument. It also manages to get nitrogen dioxide, sulfur dioxide, and formaldehyde because of the wavelengths of light that it uses. I'll come back later if you want. Satellites offer the global perspective. They go around the whole planet. You get to see what's coming in from your neighbors, where your stuff is going. This one's Australia. You can see here this tan smoke that's just pouring off the continent nowadays. This was taken by the MODIS satellite that goes around the Earth, watches everybody. Because the satellites have relatively long lifetimes in orbit, a decade or even 2 for some of them, you can watch trends. So from 2005 to 2018, we did a lot better with nitrogen dioxide. We also have satellites, sensors in orbit. This one's on the International Space Station that measure greenhouse gases. Totally have to skip that for now, not even close to enough time. New satellite, fantastic, really excited about it. Another new one that's super exciting that actually do get to measure sometimes underneath with the airborne sensors that Carrie Lynn was telling you about. This one is TROPE-OMI. It's from the European Space Agency, and it's crazy better than the one on the other side. It has way better spatial resolution and just as good quality because technology has progressed. All right, time of day left to right. This is smog. Just treat this as smog, and the red line is the time of day that these close-in satellites go over. 1:30 in the afternoon. That's it. That's all you get. 1:30 in the afternoon. But you can see the smog changes during the day. So now what we need to do is get that chemistry information throughout the course of the day. We have to go out to geostationary orbit to do it. Here's one that's going to do it. Carbon dioxide and methane and the biosphere for the carbon cycle. But this is the one I really can't wait for, which is the TEMPO mission. It's going to be the chemistry. This is air pollution every hour from 22,000 miles away, which is just ridiculous. I don't understand who managed to think of these optics, but it's going to be amazing data. You're going to be able to get even better air quality forecasts. We're going to be able to do a way better job at monitoring the health effects of air pollution We're going to be able to do a better job of regulating. We're going to know what regulations work and which ones don't. Thank you very much for letting me tell you all about this. And thank you for the tax dollars that funds just about all this work, because seriously, if governments didn't do it, who would? And then I want to play a video. So these are NASA satellites in orbit. Not real time, but this is what it looks like. And actually, it's a couple years out of date, but just so that you can see that we're constantly being orbited by low Earth orbiting assets to study all sorts of different things about our planet. I didn't even talk about the solid stuff.
Sorry.
Yeah.
How frequently do one of these get taken out, like something happens to it, maybe space debris or something like that?
Usually, they do very well, and the lifetimes tend to be a lot longer than they're originally spec'd for. The ones that go out of service the soonest are the ones with either that need cryogenic, consumable cryogenics, that they're launched with so much liquid nitrogen and that's all they have, and when it's gone, it's gone. There have been a couple laser failures that I think are really just sort of age-related, but they tend to be more about age-related than orbital debris, because there's a really good tracking system, and they're pretty careful about stuff like that. But there have been a couple of close calls that I think we don't really hear how close they were until you see the lines and the foreheads of the people who were involved in preventing the actual impacts.
There was one today, I think. There was one where two satellites were going, I think they said about 15 meters apart was one of the estimates.
Oh. That's pretty rough.
Today, this afternoon.
6 o'clock Eastern.
Oh,
Yeah.
Goodness, was that?
It would have been front page news that hit, so apparently they
Oh my goodness.
Yeah.
Were they science satellites or communication?
I
gotta look that one up
saw the
because-
headline.
2 defunct communication satellites, US International. Right.
Ah, okay, thank you.
One was not communication, it had a big telescope.
Oh, you're right.
Infrared.
Yeah, it was you're right.
Oh, goodness.
So it definitely happened.
Yeah, and the one that that my colleagues were most concerned about was there's a Chinese satellite. So the US and the Europeans tend to coordinate deliberately, and they'll put things so that they're sort of sharing the same information. But there was a Chinese satellite that was sort of crossways, and it was either below or above, and thank God it was below or above, because it crossed the track. But yeah, it's getting crowded.
Well, why don't we hear about the hole in the ozone anymore? Wasn't that like the 80s or 90s where that was a big thing? And...
Well, it's improving. It's
Okay.
definitely improving. It still goes through better and worse winters because of the weather. So the colder weather leads to a worse ozone hole, a bigger ozone hole, and a warmer springtime will lead to a tighter, smaller ozone hole. So it still has a lot of interannual variability based on the weather, but overall, things are generally improving. The holes are generally smaller than they were when they were super bad before we phased everything out. But there has been a little turn back up in some of the ozone depleting chemicals that are supposed to be illegal. So somebody's producing one of these, and thank goodness we were measuring, because you can find these chemicals pretty easily if you know what you're looking for, and if you keep making the measurements. And so the rates of these things went down, and they started coming back up again. And people were able to say, hey, somebody, we know who it is emitting these. And so we've got to be really careful that we don't make it worse again. Oh my God, so many. I don't even know how to choose. Standing up.
You mentioned the greenhouse gas satellite that you didn't have enough time to talk about. Can you talk more?
So the other thing that can make a satellite not return data is launch failure. So NASA had this weird little period of time when there were too many launch failures right in a row of the rockets. So the first orbiting carbon observatory, OCO, did not make it to orbit because the fairing on the top of the rocket that's supposed to protect it and then pop off so that you have less mass to get to orbit, it didn't pop off. And so the thing never made it to orbit, it landed in the ocean. OCO2, however, they started over, built another one, launched a second one, and that one made it to orbit, and it's producing really great data. And now its sister, which is its flight spare, because when they built OCO2, they built two just in case. OCO3 is now installed on space station, and so it has a very different orbit, which is really neat. And it has, so OCO2 operates by pointing the spacecraft wherever you want to look. because it's the only instrument on the spacecraft. You just turn the spacecraft. You can't turn the International Space Station. So as it flies over something that you want to look at, you have to be able to turn your instrument. So it has this really great gimbal system for pointing the instrument wherever they need to point it, because the space station has this wonky orbit. What it means is that you can then take the instrument and you can point the mirror across, back and forth, back and forth, back and forth, across the LA basin, or across any one of these urban areas where before we used to just, with OCO2, we get whatever we're flying over, right? In a nice straight line. Well, but LA, there's so much to map. And there's so many places where you want to be able to map out the whole city and see where the emissions of carbon dioxide and ideally methane, but not with OCO3, where the carbon dioxide is coming from. So that is super exciting about OCO3, is this ability to map out urban areas. It's super cool. I'm gonna let Kellen ask.
You can actually see OCO2 in its orbit right there.
Hey, all right. Mel, had a question?
How long does it take to get the data back down? If you map out the LA basin, do you like get excited, send this, like get that order sent in, and then wait 4 days for all your data to get down, or?
It depends on if you get excited about calibrated or uncalibrated data.
Okay.
And so the scientists get excited really quickly, but they won't publish it for a while until they're sure it's right. So I've been seeing plots in meetings that we don't say are final, right? They're clearly there's more here and less here, and it's going to be great once we get all the error bars figured out. Right now they're working on the last little bits of the pointing precision with OCO3. So.
How do you calibrate something already in orbit?
Oh, that is a whole other talk. And I can give you that talk, but not with these slides. But you basically compare it to other things that you have calibrated well. You calibrate it a lot before you launch it, and then after you launch it, you look down and make sure that it's still giving you the same answer as when it looked up. And the mirrors degrade, so you have to do it over and over again.
Is there a central repository or database where all the orbits worldwide, you can look, oh, China has a satellite there, so I shouldn't put it there. And that's one. Second, when people say spy satellite, does that mean it's doing spying and the world knows it exists, or you don't know that it exists and orbiting?
Interjection. Well, I did a talk on orbital debris at Nerd last night, so I'm happy to field any.
Ooh, I was gonna punt on this one because I don't know anything about orbital surveillance, but I know that there are people who do that completely. Like they know when there's that bolt that fell out of Tyros 1 or whatever it was that's coming towards space station. Like that's their job. So even if somebody doesn't announce a satellite, I think astronomers see them without, like the astronomers are looking past and someone goes by with a satellite there, right? Mm. So I think they're kind of known where they are, even if if it's not known maybe whose they are or what they do.
And is there a database where you can see where all the satellites are?
I know there are a couple of web tools. I'm sure one of them is operated by NASA, where you can say, oh, I want to see the current orbits of such and such satellite. But I don't know that they are meant to be inclusive of everything that organizations who don't advertise what they're flying are flying.
NASA one is just the US, not...
I don't know. Actually, I haven't played with it lately.
But then how do you launch a satellite in maybe in path of somebody else's?
Oh, people who do this know this. I'm a chemist. Yeah. This is like people's jobs. Yeah, so the geostationaries are actually going to go on communications satellites, and the geostationary orbit is very far away, so it's a huge circle, oval, but the places that are directly above where you would want telecommunications are already very crowded. So orbit real estate is a big deal, especially at GEO, because you have to be right on the equator. So you can't just go over here and find more space. You have to be right on the equator to get the geosynchronous part of your orbit. So it's a resource that is managed, I believe. But I don't know that there's any sort of international convention or anything about it. I think it's just whoever's going to launch one says, okay, we're going there.
Anybody else? Oh.
So, in the last couple slides, you had some things about really exciting projects that are launching in 2022, 2023.
Yeah.
And then you mentioned tax dollars. And so I was wondering if there is concern at any level about whether or not the tax dollars will actually allow that to happen in 2022,
Get
2023.
over the trend.
Or if the funding cycles are longer than that, or if
So-
it failed.
Laura, comma, a private citizen who lives in Mountain View, California, comma, would like to share her personal opinion on this subject. NASA's pretty conservative and doesn't commit to a mission unless they can pretty clearly see they'll have the money at least sort of for the first decade. So these projects are 20 years long, minimum, right? From the design, someone pitches an idea. So take the Tempo satellite, for instance. Guy named Kelly Chance, who works for the Harvard-Smithsonian Observatory, has been working on these sorts of instruments all his career. It's probably his third or fourth one now. He's the famous guy who designed that technique for this satellite and that satellite. And so he said, okay, I'll take the challenge. I'll propose to you a mission to go to geostationary to do the same thing that I know how to do in low Earth orbit. That was, let's say 6 or 7 years ago, that idea became a document. And I don't know how many times he submitted it before he won. And there's one of these opportunities every 2 or 3 years to propose one of these missions to NASA. So I don't know how many times he had to try to get selected. Then he got selected, and that was 5 or 6 years ago. And the instrument physically exists, and they have now signed a contract for who's going to mount it on their geostationary. And the thing doesn't even launch until 2020, and then it's going to run for 5 years, hopefully 10, but they'll only promise 5, So it's going to be a 20-year project. So NASA tends to be pretty conservative. They say, here's how much money I can give you, project, and you have to stay inside this budget. And then they won't start another project until they're confident that they're going to have money. All that being said, there is a big drop-off in capability coming. So all these things that are in orbit right now are 20 years old, 20, 30 years old. And they're not going to last forever. These are the ones who didn't have cryogen, right? These are the ones whose lasers haven't failed yet, but someday they're going to fail, and then there's nothing. The aerosol particles, the particulate matter sensors that I didn't talk about at all, there's a gap in that capability coming in 10 years or so when the current ones die. There's nothing that's already being designed. So when they start designing it from scratch, there's going to be a gap. And so that's where I think the problem is going to be, is that we don't have a big bag of money that says this is for the future. Go ahead, come design the sensor we're going to need in 10 years with this big bag of money. Yup, the bags are getting really small.
Yes.
You mentioned that the ozone is doing a little bit better. Is there anything else that's also improving? I hear a lot of negative things. So is there something?
Anything good happening in the world?
No. I heard.
Long pause.
Sorry, millennials. Well, so in this country, air quality is way better. Things that I didn't realize
There was a slide of that.
really did happen in my lifetime. Not that I'm going to tell you how long that is. But I didn't grow up in California, so I didn't know what LA looked like 2 decades ago. But LA is way better. Apparently there didn't used to be mountains in Santa Clarita. You could only see the roller coasters and no mountains. Now you can see the mountains most days, right? So that's real, and that's sort of within the last 2-3 decades. So here's NO2. It's made a huge improvement over the northeastern US. So in the US, there is that sort of improvement, but there are still obviously places in the world that are worse than LA ever was. But I get the sense that there's awareness and some amount of desire. And I chuckle, but I also take some hope when you hear these little anecdotes like when China had the Olympics and they wanted to show the world their beautiful city, they forbade industry and traffic for a week to clear the sky. So there's a tangible value in clean air and clear skies. And that's what it's going to take, I think. So that's kind of where I take my hope, is that more people around the world are seeing value in what we've been able to do in places like LA.
Thank you.